In this video, we're going to learn the various ways that we can use to create form bodies. Hey everyone, this is Matt with Learn Everything About Design, and I decided to kick off a new series that's specifically focused on mastering the Forms workspace. Now, we've already done a couple of introduction to forms in the Fusion 360 course. We have talked about forms in our Subaru WRX and our Ferrari 308 series, and I really think that actually attempting to model something complex like that is a great challenge, but I also wanted to come back a little bit and focus on some of the basics so we have a good foundation for building anything, not just trying to follow along making a car. So we want to get started by first downloading the form creation dataset that you can find in the description of the video. It looks pretty blank, but there's one construction plane and there's a whole bunch of sketches in here. The first thing that we want to do is we want to start by going into Create Form. When we go into Create Form, we have the Create dropdown that allows us to sketch directly in here. And we've already taken a look at creating planes, and we've also looked at some of these other primitives in the past. So I want to focus on some of the differences between using these form tools for things like extrudes and revolves, and how those relate to creating surfaces or solid bodies with them. I also want to talk about this option, pipe, which is pretty cool and something that can be very useful depending on the types of things you want to model. But first, let's get started understanding the basics of some of these what are considered Boolean operations. So first, let's go ahead and take a look at our sketches, and we'll start with extrude. When we take a look at extrude, you'll probably have to zoom out, and you'll note that this is a fit point spline, and it looks kind of like a bean. Now, the reason that we want to take a look at this for an extrude is because there's a unique thing that happens when we use extrude in form bodies. We're going to select our profile, and then we're going to begin pulling this up. One thing that you can see here is that the outside profile of our spline is not exactly matching the shape of our extrude. And this is really down to the number of divisions that we have. You'll notice that the spacing is based off of curvature, which means that in areas where we have high curvature, the edges will be closer together. In areas of low curvature, they'll be further apart. If we change this to uniform, it gets even worse. It's not even close to matching our shape. So we do want to stick with the curvature spacing or displacement of these edges. Then the next thing we want to note is the number of faces. Now the spline was originally drawn with 1, 2, 3, 4, 5, 6, 7, and I believe there might be an eighth one in there. 7 or 8 spline points. But that doesn't translate to the number of faces that we have. When we think about these splines, let's go ahead and hit cancel on this. When we think about these splines, we really need to think about the way in which they're created. So this spline, again, was done with the fit point spline. If we go into a control point spline and we try to match this same shape, we're going to have to come up and then back in and back down and come back around. And that looks pretty close. We want to make sure that we do close this off with tangency. And this actually might mean that you have to take this handle and make them collinear. But you can see that now we can sort of manipulate these around and we can get close to that same shape. I am making it a little bit offset or different. But one thing that you'll note is the number of points that we have, or really the number of faces between them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 in that case. But the original fit point spline was really looking at points on the surface or on the curve. So the difference between that original one using extrude and the one that we drew with the different type of spline is that we had more faces. So if we increase this to 13, you'll notice that now our spline is a little bit closer to the form body. It's not perfect, but it's getting much closer. We can increase this until we get it as close as we need for whatever we are trying to design. Now, the problem that we run into here is in order to get this shape, we're starting to add a lot of divisions. We're up to 25, which means that controlling the shape is going to be much more difficult. So if you're trying to create a shape like this based off of a sketch that's a spline, You're really starting off going down the wrong path because the end result is going to have way too many edges or vertices to have good control. I'm going to say okay and create this thing, but just note that this method of using Extrude for a form body already starts you off on the wrong foot just because of the level of control. Next, let's take a look at a sweep profile and a sweep path. If we were going to do this with solid or surface bodies, it's pretty straightforward. We pick our profile, we pick our path, and then we create our surface or solid body. This works actually pretty well when we're talking about form bodies. You will notice that we do have issues where we have some overlap. And in the case of doing this with either a surface or a solid body, that would instantly become a failure. That would cause it to be self-intersecting. However, with form bodies, it allows us to do this. What we can do is we can begin manipulating these curves by double-clicking on them, maybe rotating them and pulling them just slightly. And we can adjust these curves just so that way we don't have that overlap. We can move things around. And then we have this curve here. We can potentially pull this down. And if we go back to smooth display, that still looks pretty good. But using the sweep type of function inside of the form tools allows us to get something that's more of a uniform pipe, and we don't run into some of the same headaches that we do when we're using things like surfaces or solids because it won't allow those self-intersections. Whereas in the form workspace, we can have overlapping form edges and vertices. It's not good practice, but these are things that we can actually use the form tools to fix. So sweep gets a thumbs up from me. Extrude is kind of a picky one. You need to really be using straight lines or arcs and be really careful with the curvature because it can get pretty ugly pretty quickly. The next thing that we want to talk about is going to be Revolve. So let's take a look at Revolve. We're going to go to Create, Revolve. We're going to select our profile, and then we're going to select the axis of revolution. So this one, again, you can see has the same problem that we had with the sweep. We had some straight lines in this profile, and we also have a bunch of arcs. There are no splines here. But in order to match the curvature, we're going to have to start changing the number of faces. So if we take this up to, say, 15 around, and let's take this up to 25, now we're starting to get closer to the actual shape. In this case, we have a benefit because we can include circular symmetry, but that symmetry is based off of the number of faces that we have here. So for example, if we use 4, then we're dealing with a quarter. If we use 8, we're still dealing with a quarter, but now we have these eighth divisions. So you can see that this is, again, it's a valid method, but we have to be extremely careful with the level of detail that we have. You can see that the number of faces or divisions under here is extremely high because of that 25. And the more that we drop down, the further and further away we get from that original profile. If we go down to something more manageable, say 10, it's not even close to the same shape. So depending on what the end goal is, something like this shape is really better suited to something like a solid or a surface revolve. We can certainly deal with it in forms. It's not something that we can't do, but when we're talking about really truly matching the shapes that we need, the number of divisions that we need for a revolve like this, it's going to be at least 8 around the perimeter. And in this case, it's looking like 25 or 26 is going to get us close to that actual shape of the profile. So again, it can be done, but then we run into issues of how are we going to control this thing? We're going to have to go in and add symmetry. In this case, we probably don't want to add circular symmetry. We might want to add mirror, and I can just pick faces across and determine whether or not I have a mirror line. But again, it becomes a much harder challenge for us to control. The next thing that we want to look at is Loft, and for this one, we're actually going to bring back the Extrude, and we're going to go and Loft between those as well. So again, we're going to just go to Create, Loft. We need to pick our profiles, and because they're not connected, they'll automatically be created as a start and an end, or a profile 1 and profile 2. Then we can determine the spacing, if it's going to be curvature based or if it's going to be uniform. And you'll notice that as soon as I do that, when we make it curvature based, look at the number of divisions we have. It's based off of this deviation, and this deviation slider is going to determine how close to that original shape we want to get, or we can use uniform and manually increase the number until we get a little bit closer. So you'll notice that this method, again, what's going to happen is we're going to have a lot of divisions. We ended up with 13, and because of that, the shape becomes much harder to control. So if you're starting with a shape that is already smooth, you're working with splines or you're working with a lot of arcs, just generally making some sort of starting sketch or profile that is smooth, that is likely going to point you more towards using a surface or a solid tool in the design workspace than it would then starting out with these form tools. So now that we've taken a look at those different methods, let's also talk about pipe. Now, pipe is an interesting one, and I made this sort of box sketch in 3D. And this sketch contains an outside sort of rectangular box, and then I've got lines between in the center. And this is really where the pipe tool shines. And we're going to take a look at this, but first we're going to modify the global diameter. I'm going to make it 10 just to make it a little bit smaller. Then we're going to begin selecting paths. So when I do this, you'll notice that it looks like a cube, and that's because it's in box display mode. We can switch to smooth display mode, and we can continue adding profiles. So for example, if I move my way over to this side, let's go ahead and rotate this around a little bit and just begin connecting these. You can see that I'm building this sort of pipe structure. Now, this is extremely helpful if this is the starting point that you need for whatever it is you're designing. If you're trying to make an organic looking tube structure or frame, or trying to make some sort of custom lattice, then you can do that. We also have the ability to sort of make these connections, and you can see that I'm doing this by, again, using the sketch, where I have that single node in the middle. Where this becomes problematic is when we start to add too many, we get these situations where we start to have pinches. Now we can take care of this a few different ways. First, we can go to the segments and we can reduce the number of segments. Reducing the number of segments is still going to give us a very similar shape. The corners will be more rounded, but we also have less to worry about with these intersections. We can also do things like display the curve splits. And when we display those splits, you can see here that we've got 4 curves intersecting here. And we can actually adjust some of these values on the fly. So for example, I can increase or decrease the number of segments in certain areas. This one has 8. I can increase those if I want to get more control in the areas where we have these intersections. And again, we've got on-screen manipulators, and we can also manually increase those values. But the curve splits are showing us how many we have coming together. Now, 8 is going to be more than we really want to handle. That's going to be really complicated. And 4 is probably okay, but again, it's going to be problematic. So if you are planning on using this tool, the way that I suggest doing this is to create this pipe structure and then really think about the way in which all of these things are intersecting. What we can do is we can double click to select sort of these edges and these loops that go around, and we can delete some of them, and we can begin sort of changing the way in which this control happens. So again, if I start deleting some of these edges, I can begin removing some of these pinch points that are created and really changing the way that this thing blends. So once I get rid of those and go back to a home view, you can see that now if we remove the edges using Control or Command 4, we're starting to get a little bit smoother division. We still have some pinches in some areas that we need to deal with, but these can be found by going to Box Display, and you can see how the box display is twisting. These 4-sided patches are actually not truly 4-sided. So these are things that we need to come back and potentially weld vertices to clean up some of this geometry. We can weld these together. And you can see really down far in here, it's kind of hard to tell, but it looks like there might even be 2 vertices there. But again, these are things that we're going to have to manually correct and work at to figure out what the best way is for us to get the resolution that we need and the shape that we need. So if we go back to a smooth display, you can see that we inherited some additional problems, but these are all things that can be fixed. So again, it takes a bit of time, but this is kind of a cool technique for us to use, especially if we are trying to create something that is a little bit more organic. Using the tools that we've already explored, and we will talk about more in this course, such as insert point, will allow us to go back and recreate those divisions to add those additional controls back in Once we have the shape that we've started with and we're happy with it, then we can go back and we can start to divide these up and add that control back in. So I'm going to just do that real quickly on this model so we can see. Rotate it around, make sure that I do have that vertex. We'll go to this one, and we'll go back up to the top. So now we've sort of broken those back up. We can use additional tools like Modify, Edit Form. I'm going to go to the top, and I'm going to scale these because I selected ones on either side and sort of push them out. And when I look at this in Smooth Display, you can see now that we're getting a little bit better result. It's going to take time, but those intersections are really tricky and something that pipe doesn't really do well. It doesn't handle those well. And again, you do have control inside of the pipe tool when you're creating this to sort of work and manipulate this, but it's going to take a little bit of manual work if you try to go too extreme with this. So if you're trying to connect more than I'd say about 3 intersections, then you're really going to have to spend a lot of time working on those intersections manually. Not the end of the world, but again, it's still another method. And lastly, I do want to mention that we have already talked about some of these primitives. We've used face and plane before. Box is a standard one that people start with. Cylinder is one that we've used before as well. And each of these sort of have their own benefits. When we look at the difference between a quad ball, for example, I'm going to go ahead and just make a quad ball here. And we go ahead and we take a look. Let's go ahead and expand our bodies. I accidentally finished the form, so let's go back into it. Let's hide all these other ones. So when we take a look at the quad ball, and we want to look at the differences between quad ball and sphere, let's go ahead and just make a sphere over here. We really get down to the difference in the way they're divided. Now, if you see all these ghosted images, it's because the surfaces are manually displayed here. And I can go back and I can just hide them back in the design workspace. Then I can hide them as bodies here and their ghosted images won't show. But we can see here that the way that these two are divided up is very different. Now, on the surface of it, it looks like they are the same shape. If we were to use Control or Command 4, they look the same. But there are some inherent differences, and the reason why you would choose one over the other really depends on your end goal. In general, and I've mentioned this before, and we'll talk about this in the next video, but in general, we want to avoid 3-sided or more than 4-sided patches. So anything that's considered an n-gon is going to be a patch that has 5 sides or more, or these triangle patches. These generally give bad geometry where they intersect. Now, when you first make this sphere, it looks fine, but as soon as we begin to manipulate it, that's when we get into trouble. If we were to try to select this vertex at the center, you can see that it's really difficult. So I'm going to move over to vertex selection and I begin moving it out. You'll notice that it's not actually connected to the rest of them. That center wasn't welded by default, which means that this is going to give me a really poor result as soon as I start to manipulate it. So in most cases, unless you are actually going to remove the top and the bottom of these, so for example, if I just select and delete those triangles, so unless you're going to do something like this and work with it truly as this spherical shape, I would aim to use a quad ball. And of course, generally I will start manually by using either a face or a plane, and that'll be my starting point. And when we get started modeling something, that's exactly what we're going to do. We're going to use either a face or a plane. The last thing I do want to note is that we have a mix of solid and surface bodies here. And the reason that we have a mix of solid and surface bodies is because when we created these different surfaces using the form tools, if they were open surfaces, they're converted to a surface back in the design workspace. If they were completely closed, like the quad ball, then it's going to turn into a solid body. That's true for things like the pipes. So that is a solid structure. That's also true for things like the Revolve. The Revolve was completely enclosed, so this right here has turned back into a solid body. Anything that was left open, like the sweep, the extrude, or the loft, these are all coming in as surfaces. And then we could use additional tools to cap them off and turn them into solids. Things like patch. We can patch the top, we can patch the bottom, and then we can stitch all 3 of these together. and Fusion will automatically take those, assuming they're closed, and turn that into a solid body. You can see now we've got that solid body. It'll show up as a solid here. But again, there are inherent problems in some of these processes. And just essentially through practice, through figuring out what works for the types of things you're modeling, you'll figure out what is going to be your go-to type of form. For me, it's going to be the cube. So the box or the cube is generally the primitive that I start with. And then I can sort of work from there to create anything I need. And also using, again, either a plane or a face. If I'm modeling something more complex like a car, then I'll start with a single face and I'll build off of it from there. Gives me a lot more control than having to work with a body like this. So hopefully that was a good introduction into how we can create different form bodies using various base sketches and really what the implication of that is downstream. What I plan to do from here is to continue on with this series, talking about some of the basics, the understanding behind how to get started creating form bodies and what some of the basics or the ideas are behind that. We're not going to be using any references or blueprints or sketches behind the scenes. We're going to start from scratch and we're going to learn the process of manipulating it without having to focus too much on matching a predefined shape. So we're going to get started in the next video by creating something brand new from scratch and learning some of those basics that we want to follow. If you have any questions, please let me know. As always, thanks for watching, and we'll see you in the next one.